That would have been nice to have my mic going. Anyway, let me start that all over again. My name is Kevin Lagore. Welcome to Skywatcher USA What's Up Webcast. Sorry about that. I had my mic muted. Today we have Mike Lockwood from Lockwood Custom Optics. If you've never had the privilege of using one of Mike's mirrors, they are astounding. Mike is really one of the forefront opticians in the hobby. Even regret to say the hobby because he's doing a ton of stuff beyond the hobby. But he's making fast optics for Dobsonians, Newtonians, other mirror-based systems, and large apertures as well. So today we're really going to be focusing on, if you're looking for a dream system, you want to know where things go beyond what we do here. Mike is the next tier up. So we're excited to have him here today, and I'm going to go ahead and bring him in. If you do have any questions, go ahead and save those to the end, and we'll be happy to get to those later on. So without further ado, let me drag my face off of here and bring Mike in. So, and turn your mic on, of course. Okay. Thanks, Mike, for joining us today. I know you've got a really busy schedule with polishing tons of glass, but we're really pleased to have you here today. How are things going over in Illinois?
Illinois is still here. That's about all I can report.
That's all we can report. So I like to start a lot of our webcasts off with really just having it be pretty casual, because we've all gotten started in this hobby one way or another. So I like to ask every guest we have here, how did you get started in astronomy?
Well, I was born and grew up for about the first 15 years of my life in northern Michigan. And at that point, it was ridiculously dark. And we had those wonderful Canadian high pressure systems that would come in the summertime mostly. When they come in the winter, that it's very cold, but you get really clear skies. You know, you can kind of see that deep blue hue to the sky, you know, as an astronomer, and know that it's going to be a good night. And we had that a lot, you know, really clean, really often low humidity air. And so you couldn't help but notice the sky. And at some point when I was growing up, I did. And I decided I needed to learn about it. And that started things. And then a few small telescopes here and there. And eventually I decided that I wanted something bigger. But my parents didn't really want to pay for that. So I thought I'd try to grind a mirror. And that started somewhere in the late 80s, roughly.
Nice.
I'll have to have you guess when I actually finished it, or we could get to that later on. One of the two.
I know mirror making. I have several friends of mine that, I'm sure you're familiar with, like Mike Spooner and other opticians, their own mirrors. But that was really kind of the thought process back then, where we're starting to have some of the, like, the C8 was coming around and all this other stuff was occurring, right. But you know, you're just getting into the hobby. That's at that era, that's a lot of money. It was a lot easier to make here at that point and grown, kind of take the John Dobson mentality.
Yeah, and this was probably, I think it was sometime after Halley came through, and we did get to see it, but it was really low, you know, because I was up north of 45 degrees latitude. So as I remember, it was down somewhere Sagittarius or a little bit east of there, if I remember correctly. I may be completely wrong. But I remember just looking low, and we could see it as a smudge through the binoculars, because at that point didn't have anything better. So yeah, it was at some time after that. I don't know if Halley really caused me to get more interested. I remember being a little bit disappointed at the view, which, you know, that wasn't a very favorable opposition. But I think that may have given me the idea maybe to do something a little bit larger in the future.
Mm-hmm.
So started an 8-inch mirror kit.
Yeah, that's aperture at that point. So having said that, and now that you've kind of established that you're making mirrors, now segued into the modern era, what are you I know you've got a bunch of toys laying around at this point. Since we're all astronomers and we all like to kick around what are you using? What scopes are you currently using?
The easiest one for me to set up right now, other than just using a straight night vision monocular, is the 20-inch f3, because I can just roll it out and do a quick collimation in about 2 or 3 minutes with some good laser tools, and then wait for it to get dark. So it's real simple. And
Nice.
that's, of course, the key to observing a lot is make it easy to do and not a ton of work to get set up and torn down, because otherwise you just don't want to do that. And then you tend to do other things.
Yeah, and that's, we try to tell a lot of people that when you're trying to get a telescope, if it's going to be too big, because we all want that big, 30-inch scope, and Mike can definitely attest to when you have the abilities and the location to support something like that, it's definitely worth having it. But, on a regular night where it's like, I'm going to go look at, the comet, it's like, well, I'm not going to roll this thing out for 30 minutes of viewing. So,
I did roll the 20-inch around the house farther. I took off the wheelbarrow handles and then realized the comet was in a good position. So put them back on really quick, dragged it across the lawn carefully and slowly, and got some views that are actually, I took a few photos and they're up on my night vision page. So you can drag a 20 around pretty easy. A 30, it would be a little bit more challenging.
yeah.
But, up to a certain size, if you're clever, like you mentioned when we were just getting ready for the webcast here, seeing one of my clients' telescopes called Elvira, which has its own transporter that can pick it up, and he can just drive it around. It's a motorized wheelchair base, basically adapted to move a telescope. So I hope to see more of that in the future from people, ways to be clever and still be able to, set up and tear down quickly, but also move a 250, 300-pound telescope around, with little effort. We've got the technology.
Yeah, and rebuild.
Yes, we can.
If any of you ever have a chance, if you're wondering what about the scope Elvira that Mike's referencing, you can go on like cloudy nights. The gentleman who built that telescope has a whole form on all and it's still going because he's still modifying things and doing things to it. But that's a 24-inch, what is it, f2.75?
You got it. And I'm actually, at some point, I need to either do an article on it so that he has some sort of fixed reference on the internet, because he doesn't have a web page. And then more people will probably be able to see it because it'll be easier to link to and just go in directly and read a story as opposed to a multi-page thread on cloudy nights.
Yeah, with multiple thoughts and
interruptions, distractions, segues to other things, and then comes back. Yeah.
But if you ever get a chance, he comes out to Texas Star. I forgot his name. He's very generous with that. It's Ed. That's right.
Ed Allen. Yes, he. TSP. He had a big adventure getting there on some really bad roads and had some damage to his truck. So I'm not sure if he'll be able to do that again. But typically, Okie-Tex Star Party, and then he's up in Montana, so he will go to some of the Northwest locations and star parties occasionally. But I'll let him, if at some point I'll let him, somewhere maybe on cloudy nights would be willing to talk about his schedule.
If you ever get a chance to see it, it's a very cool scope. Ed's a really great guy. He's been really, if you're out there on the field and you want to take a look at this just crazy scope, he's very generous with it for anybody who's willing to.
It shows what you can do if you think about it, and if you have the knowledge and some skills. He's an electrical engineer originally, so we have a somewhat similar background, but he actually went and built stuff, whereas I ended up doing a little bit different avenue with research and then starting optics. But it's just great to see all the ideas just come to fruition. He just makes it happen. Make it so.
Yes.
And it happens. So he's a great example of what you can do with a very fast mirror in a very well thought out structure. And there are some other structure builders I'll mention later that are doing a really good job. That's the key for fast optics: is put it in a good structure and then enjoy it.
Yeah. I know you have another scope we've also seen before. If others haven't seen it, it's a 14.5-inch f2.5, and this was kind of built on almost a conceptual thing first to test the Paracore 2 at the time. But
yeah, I think it's actually it's
yeah,
sitting on a
back
part
there.
rack here behind me. I might be able to roll up part of it in a little bit, but yeah, f2.55. Originally conceived in about 2009, I believe, and I called it, and the name tag's still on it, I called it the Paracore Buster, because we wanted to see just how low an F number the new Paracore, the Paracore 2, it was new back then, now it's all they produce, how low an F number it would work at. And so if you go look at my Okitex, I think it's either 2009 or 2010 article, you'll see pictures of Al Nagler testing it, and we had a good time just seeing what would happen. And it turns out it works reasonably well, down at that speed. But I'll use this little point to say, this opportunity to say that what I recommend for really high quality observing would be f2.75, 2.8, or slower. Just given the limitations of the eyepiece and other things. For night vision, it's a different question. You want to go as fast as you can, and the f2.55 is the most fun telescope for night vision that I probably have, because it has a huge field of view, and it's the fastest, so it produces the brightest images. And we can go into that more if you want to later on, but I'll let you get to your other questions.
I guess we already did the first one. You started making telescopes on your own in the 80s at this point. When did you...
I started a mirror in the 80s.
Started a mirror.
I finished it in 2003.
There you go.
Yeah. There was high school. We moved to Cincinnati, and I joined a club there, so I had telescopes to use. And I kept working on it, and it went from something like f8. And finally, when I pulled it out of the box in 2003, when I had some time, it was about f3.9. And that ended up being my first mirror. And the first telescope that I built from one of my own. I built a couple before that, a 10-inch and a 5.25-inch.
So when do you get to the point where you're like, okay, I'm gonna start making mirrors from a business standpoint? Because I know as a hobby you can, do that really easy. I've got a lot of friends that do it, but there's a teeter point where it's like, okay, I'm making good enough stuff now that that's worth going.
You kind of compare with what's out there, and I didn't really make as many at first as I did fix them. So you take what you call a professional optic, and you have a look at it, and you say, well, I can do better, and you fix it, and then you maybe do a few more, and then that starts you to think. You start thinking about it a bit and pondering, and it just kind of happened. Things built up a bit more and more. That's what I was doing in the evenings, working at the university, doing digital signal processing, research during the day, and then I'd come home and work on mirrors or work on telescopes or whatever.
Cool. I know it's someone who works in the telescope industry, and I know being one of the more hands-on opticians out there, it's really kind of a leap to take a jump into this world, because it's kind of small, but I'm glad you're here in the world making these mirrors, because it really revolutionized the way we look at big mirrors and telescopes at this point, because making things that used to be 15 feet tall now pint size at that point. So
it's all about ergonomics, and it's just like being able to move the telescope. You also have to want to be able to, or you need to be able to use it in an enjoyable manner, and not have it be an endeavor. And some people don't like ladders at all. Some people don't mind them. It's fatiguing though to stand on a ladder, and you get more quality observing time if you can be standing comfortably or sitting. Depending on the size of the telescope, really. But with my 20-inch f3, I can almost sit and observe over the entire sky with a good chair. And so that saves a lot of energy at night. People may not realize it, but it just makes for a much more enjoyable evening.
I know, at Skywatch we make a 16, 18, 20s, and they're nowhere near as fast. But I've seen like a 20-inch f3.3 from you, and said earlier a friend of mine has a 20-inch f3.
Same as mine, yeah. Same class, yeah.
So, for any of you who have seen our 16, it's a standard f4.5 as you would expect from a mass production company. They fit their needs, but having a 20-inch scope that's actually shorter than the 16 is freaking awesome, is what it is. Yeah. But it really is impressive how you can go longer in the night and be more comfortable and use your scope more and still get that aperture punch that we all want when it's easier to take out.
Yeah.
Big deal.
So it's also an advantage for those who observe with night vision, because it's like a photographic plate, film, or CCD. The faster the system, the faster the image gets bright, or the brighter the image if you're viewing in real time, like with night vision. So it was I didn't even think about that back when I started making fast mirrors, but now it's become a lot of fun, and it's another advantage of having a fast optic. Of course, the trade-off is the optics cost more because they take more time to make. It's as simple as that.
No, I think when you start, I've owned large Dobbs, and I know we talked in the past about large mirrors before, and eventually and I know you deal with this daily, but you have people calling in where it's like, this is the dream scope. This is the scope I've worked for years, and I want to make it all in. So, spending that extra money on those fast optics this is an investment that's going to hopefully last you years to come at this point.
This is my retirement telescope. This is the last telescope I want to build. I want to be able to incorporate everything that I want to do and take it to these places. Yeah, you have a lot of different requests and constraints that people have, and usually there's a way to, sometimes with a creative solution like Ed's, sometimes there's a way to satisfy everything.
No, it's really cool what this new iteration, not even new at this point. I mean,
it's an evolution.
This evolution has really become really a thing, and you're not even. I'm seeing older scopes that are f5 and f4. It's kind of like you can get them for a pretty good deal now because there's a lot of people that are shifting over to the faster optics.
Yeah, you can, and there's still a lot of really good deals to be had there. If you've got a good telescope that's got a good optics that holds collimation, and you don't mind the ladder, go for it. Mm-hmm. There's no reason not to. And then you can always, decide to do something else later on. Just depends.
Was there a point that you found that, because I know you said the original 8-inch was eventually became f3.9. Was there a time where you started to dabble more constantly in that faster? I know not every one of your mirrors is fast. You lower stuff every now and again, but
I'm working on an f25 Dahl Kirkham right now with a very small secondary, very tricky. So, but yeah, the point that sort of changed would be I also have to thank Rick Singmaster, who passed away earlier this year, because meeting up with him and talking a bit, I started making some faster optics for him. And back then it was f3.7, 3.75. And, we used those at Okitex. We tested quite a bit with what was then a new eyepiece, the Ethos, the magical 13 millimeter that came out at about the same time. And we realized with that and with the new Paracore, we could go faster. And that's when the 20-inch f3 and then the 14.5 f2.55 were sort of conceived, the 20-inch first. We never did anything that fast for Starmaster. We stopped at f3.3. So I've got the only 20-inch f3 Starmaster that exists. But it definitely caused us to go faster. And Rick gave me a chance to supply optics for Starmaster, and it worked out extremely well.
I know at the time Rick stopped making scopes several years ago and retired, and unfortunately passed away this this year, but you're now working with. We were talking structures earlier, but now you're working with a couple other companies that actually supply really good structures to support those
Yep.
optics. Who are you working with now?
Yeah, I mostly work with Star Structure. He's in Florida. He builds aluminum structured alt azimuth Newtonians. I I kind of get away from calling those Dobsonians because they're evolving beyond that. And he builds a fantastic structure, makes his own mirror cells, secondary holders. He does it all, and he's a very skilled metal fabricator. He's an amateur astronomer too, and does a fantastic job. For wood structures, I worked with John Pratt for quite a while. He's sort of trying to enjoy his retirement a bit more because he got quite busy in his retirement just building telescopes. So he's not really taking too many orders at the moment. He's got other projects to finish up that he wants to do. And also work a bit with Spica Eyes, Tom Ozapowski. Depending on what sort of design and drive system people want, he has a very interesting offering out there. He also makes, of course, equatorial platforms. So people have their own preference on how they want a drive system to be implemented, whether you want none, or a slip clutch like Tom does, or the full servo cat like Star Structure does, where that sends it everywhere. You can unclutch it, but that mostly moves the telescope. So lots of different choices. And the main difference I'd say is Mike Zammit from Star Structure, his telescopes are built for, let's just say, East Coast climates, because he's in Florida. And I mean places that have dew, because that's a consideration for the really minimal telescopes. They don't have a whole lot around the optics. And out west, that's more popular because in a lot of places there isn't dew. But here, east of the Mississippi, there pretty much is just about everywhere on just about every night. So you have to be conscious of that. So he kind of, builds things a little bit. There's a little more structure and there's a little bit more to the mirror box and those sorts of things.
I know being out here in Arizona, obviously not right now, you can't go see it, but if you guys actually want to see one of Mike's mirrors and a Star Structure, Lowell Observatory just put one in their new facility that you can go and actually use on any given clear night when they're open for business. Obviously, here at the end of the world right now, that's not a thing. But it's a 32-inch f3.
Yeah, 32-inch f3 with quartz optics done by Star Structure. And I also have to mention New Moon Telescopes. They're building a little bit different style of wood telescope. Some people kind of prefer that. Again, you have to go. It's best to go to a star party or go to some gathering where you can see a bunch of these things. And if the owners will let you move them around and use them and see what you like and what you don't like, then that's a really good way to make a decision for that.
I know that's anybody who's ever, I know there's a lot of people watching right now, and this is recorded, so if you're ever watching this again, if you're ever in the arena of wanting to get into these custom jobs, like 20-inch bigger, and you're not sure, you've never seen one, it's a really good idea to go to, like Mike said, go to a star party and wander around and check them out, because this is it's a big investment that you're going to be doing, and it's definitely worth taking the time to ask owners questions and emailing people and getting a feel for it, because it's one thing to see pictures online, but it's a whole thing to get out there and utilizing it. So that's...
I will also use that as a segue to mention that I have a client in Australia, and he actually came to the Winter Star Party to see some telescopes that had my optics in them and to see some different structures. And of course, in Australia, the main telescope builder there would be SDM Telescopes. That's Peter Reed. And the SDM stands for Size Does Matter.
Yeah.
So he builds a wonderful instrument. So if there's anyone watching down there that hasn't seen one of his, you should try to do that at some point when it's possible to travel to an event. And those are the major structure builders that I've done the most work with. And they've all tried to, improve their products and evolve and continue to evolve. That's the key. If you just kind of stay static, then, other things come along and people will find improvements and you kind of get left behind.
Yeah, especially with this era, where you definitely see it where a lot of people are moving to that faster optical design. So really want to kind of keep up with the Joneses on it, because if you don't, someone else, like Mike said, is going to figure that out. And
Yeah, and I've been a big crusader for optical support. The quality of the optical supports, the mirror cells, are really important because a lot of times what I would see, other than a big collimation error, the biggest problem with certain amateur telescopes would be the way the mirror was supported. And it's a little bit selfish because I don't want to get blamed for that. When you're physically bending the mirror with the mirror cell, that's bad. It's not the optician's fault. It's the cell and the structure's fault. So I've done a lot of work trying to help people improve those and written articles on it. And a number of manufacturers have changed some things. And it's really helped out a lot, especially with thinner mirrors, which is another thing that I like to do because cooling is, if you've got everything else right, if you've got good optics, if you've got a good structure and good collimation, then generally cooling the mirror is the biggest obstacle in the way of good performance. And that's what limits professional telescopes a lot of times. So they spend a lot of money on environmental controls and other systems to cool off the optics. So a thinner mirror has less mass and it actually cools. Let's say you have a mirror that's half as thick as another one, that mirror is going to cool about 4 times as fast. And that is a big deal in places where the temperature drops really quickly.
I know you're working with different substrates too, and one you mentioned earlier was quartz, and I know everyone's familiar with Pyrex and borosilicate and stuff like that, but what is your thought on quartz? And then of course you kind of level up on top of that and you get to the more exotic zero expansion like Zeroder and other optical materials. But what's your thought for those who might not know on here between the different options you can make a mirror out of?
The Pyrex and the Supermax that we have, if it's actually that material, makes a great mirror, and it's reasonably priced. Now there are a number of glasses that are lower quality that are out there in the market now in the mass produced telescopes, and we don't know what kind of glass those are made from. And a lot of times the glass can have annealing issues, meaning it's got internal stress and it might change shape or do some funny things as it cools off. So generally I avoid that and I stick with Pyrex or Supermax. They're somewhat equivalent. One's made by Schott and the other one was made by Corning, and they still make some of it in certain forms. And those are a standard borosilicate. That's the type of the glass. And it does change shape a bit as it cools. It's got a coefficient of expansion that is about 6 times larger than quartz. So if you have the same mirror, it's more of a consideration for astrographs, really, usually, because the focus position will shift. Because the mirror literally shrinks as it cools off at night. So the mirror gets a little bit smaller and the focal length gets a little bit shorter. But as they're cooling pretty quickly, Pyrex and Supermax are going to distort a bit more temporarily than quartz will as it cools off. Now, if that's happening, you got a big temperature swing, you're probably not going to have great seeing or great performance anyways. So it depends heavily on the user and what they're doing with it and their environment. Quartz is a really nice material. It costs a bit more. It's not really much different structurally. That gets exaggerated a lot. It's mostly the thermal performance when it's cooling off that is the advantage of quartz. Now, if you have an environment where everything's in equilibrium, everything's the same temperature, like the Florida Keys where they have the Winter Star Party, the temperature kind of drops to about 70 degrees at night and just stays there. Then everything gets equilibrated and the glass type doesn't matter at all at that point, as long as you're cooling the same manner. So it's only during that transition point. But if you've got a huge temperature change all night, quartz will help a bit. And for stability for astrophotography, it's very helpful. Now the higher dollar stuff, Zeroder, I don't really see a lot of reason for the typical amateur astronomer to go to the expense of it, or clear ceram or ULE or anything like that. It's vastly more expensive. I think quartz is by far the best bang for the buck for people that want something a little bit better than Pyrex or Supermax.
That would be, I guess that brings up a good bullet point, is if you are looking at these scopes or looking at having something like this made, knowing your environment, your observing conditions you're working in, going to be something that's going to really depict on it's worth the investment of that higher end material or not for.
Yeah.
So
yeah, and it depends on a bit what you enjoy observing. If you really want to go as faint as possible, and that's where your budget's going, then you can get a bit larger mirror out of Pyrex or Supermax.
yeah.
But if the money's not really an issue, then we just go with quartz if possible, if it's available in the particular dimension that's required. And I can get quartz up to about 42 inches in diameter right now for reasonable pricing. To go larger, it gets custom and it gets very expensive very quickly for all of the operations, but it's still possible to do.
Sure. One big thing that I see a lot is there's a lot of common misconceptions about faster optics. One of those is because it is a faster telescope, you obviously need a larger secondary, therefore reducing contrast. And then, of course, the second argument that comes from it is, oh, it's faster, it's really hard to collimate. What are your thoughts on all those? Because I know if you have written articles on your website that actually depict all this in detail.
We'll talk a bit about it. Yeah, collimation, I use a Howie Glatter laser, just a simple red dot to collimate the secondary in my 20-inch f3. When I roll it out, it's usually not that far off. That takes about a minute. And then I pop in the tube lug and pop that in the focuser and squat down and get behind the telescope and turn the collimation knobs a little bit. And that takes about a minute. And then I observe. And if it's an exceptional night, I may do a tiny little tweak at some point because that structure may shift a little bit. And I just do that with a star test, just defocusing a star. I kind of go over that in one article. And with all of that, spending 5 minutes, I get excellent performance. So collimation with the proper tools of a fast telescope, or just knowing what you need to do with a star test, it's really not difficult once you learn it, and it takes very little time. So it is easier to collimate a slower telescope because you have a bigger tolerance, but the job for at f3 or even faster is it's quite doable. If anyone tells you it can't be done, then they're just wrong. I've done it hundreds and hundreds of times, and so have my clients.
Yeah, it's all just about having the good collimate. And I know earlier you mentioned having a good structure to support it is a big support for that.
Yeah, we're raising the standards a little bit on the actual physical construction of the telescope and the collimation tools, but that makes it completely attainable, completely doable. I don't see distorted stars. I don't see coma in images in the center of the field. And there's basically in terms of tolerance, if you can't see it on a given night, then it doesn't matter because you're usually seeing limited anyways. So once you get to a point where you're better than the seeing, go enjoy your telescope.
Yep.
As for the secondary size, the faster scopes do require a larger secondary, but typically in the sizes that I work in, which is usually 14 to 16 inches and up, it's below 25% obstruction. So my 20-inch f3, the secondary is probably a little bit small. I should probably go up to a 5-inch, and that's 25% obstruction. And the difference between that and a very small obstruction, in the grand scheme of things, at a 20-inch aperture, it's extremely hard to notice. And if you have a problem with it, then just build a 22-inch telescope instead, and it'll outperform a 20-inch that's nearly unobstructed. So just a different way of thinking about things. As for the optical quality of the mirror, you still want the mirror to be just about as good, peak to valley, and slope error, keeping that quite low. As a slower mirror, it just takes more time. But we've compared, different f numbers at the same aperture, and if they're in the same location on the same night and they cool about the same, all the performance is about the same. And then you notice that people are using the shorter telescope more because they don't have to climb a ladder. It's just funny how that works out.
Yeah. you've ever been to Texas Star Party or any of these big star parties and you've climbed a ladder to a 30-inch F5 or a 36-inch F5 in the middle of the night when you're kind of out of it, it's a freaky experience.
In the dark, possibly in the wind, and it's well, I choose life, so I'm gonna try to stay a little bit closer to the ground. So that's just my thought on it. Some people love it, and there are a lot of great larger telescopes that people have fun with. But
all about you enjoying it at the end of the day.
It's all about enjoying the experience, and you spend less time moving a ladder around, going up and down it. I mean, waiting for if there's a line, it really adds time to the observing. Is waiting for 10 people to go up and down a significant ladder, and they may not be used to it, and it may take them quite a while because they are freaked out by that ladder in the dark.
Mm-hmm.
So it takes more time than you realize.
So you're working on all these mirrors, working with all these clients. Is there, and if someone's like, well, if anybody's watching and they're looking to be like, okay, I'm willing to make the jump to, handmade, this is my dream scope. Is there like an aperture size, F ratio? Is there like a sweet spot that you find a lot of customers for you tend to gravitate?
With Star Master, we kind of gravitated towards f3.3 as the fastest, and I think that's actually now the slowest usually that Mike Zammit from Star Structure will build, because his structure works best at f3.3 and slightly faster. So we do a lot of f3 and f3.3. So I'd say in that range. There are also some, f3.7 is a good spot to be as well, depending on the height of the telescope. A 16-inch f3.7 is just wonderful for portability, for what you can see, for speed if you want to use some night vision with it. That's a nice spot. 20-inch f3 or 3.3 is also a feet on the ground telescope, as our common friend Mike has talked about. And then larger than that, f3.3 and maybe a little bit faster. 30-inch f3 has turned out to be pretty popular. We've had a number of astronomy clubs that have purchased those from me and from Star Structure as well. And those are an incredible instrument. 90-inch focal length, eyepiece height maybe a little bit below that. So just a few steps up. Great for all ages to be able to go view with safely.
That's a big thing when you're doing outreach. So you want to really blow people away or all that when you're using a big job like that.
That's what the Oklahoma City Astronomy Club purchased, was a 30-inch f3. And they're the ones that put on Okitex, which is a star party that I attend regularly. Unfortunately, it's canceled this year. Too bad. But
hopefully not.
It's great for outreach, and that's a lot of aperture. You can show people a lot of things.
You did one for the Tucson Amateur Astronomy Association. Oh, I think that's 40.
Yes, 40.
1 meter at that point.
Just a little bit over a meter, 3.75. And then I did another for that. It was going to be the same, but we ended up bumping it down to f3.5, another 40-inch f3.5. A little bit short ladder.
What's the biggest mirror you actually can make? Because I know there's probably people watching that, we're talking about serious size telescopes, but what is like the biggest thing that you can produce?
Right now, I could probably fit a 60-inch on the machine without modifying it, but I can modify the machine and fit probably significantly larger than that, 70, a little bit over. Then it comes down to how big of a door do you have, and practical considerations like that. How much spacing is there between the posts that hold up the ceiling of the shop back here? Things like that, and how much weight can you move around?
Because I know you've got a cool little like jig where you can push something out from that and then hold it up to do testing on that as well. So
different tip stands, and then you can see off in that direction back there. That's a 1-ton gantry crane that my thumb is right about there. That red thing that rolls around. Sorry, I'm watching the reversed image for the webcast above, and I'm trying to point. And that's been used to lift and move 50 inchers that I've done that have been fairly thick, 1,200 pounds of fun.
So I know we're getting close to that 15-minute mark at the end, so I'm gonna just jump to the last question here, and then we'll open it up to the Q&A, and that way we can keep an hour window. For someone who wants to get into making their own mirrors, what kind of tips would you give someone who wanted to start polishing their own glass?
Have a mentor that's done it before. Have them that you can actually visit or video chat with, because it helps for them to be able to check out, in particular, pitch laps, things like that. It's hard to tell what's going on over the internet or over the phone. So have one mentor. This is what I see a lot of people get into on like cloudy nights, where they'll be taking advice from 4 different people who use 4 different processes, and then the result is confusion, and then they just want to go drink a case of beer because they can't figure out what's going on. So have one person that's done it before, if possible, teach you in person. And don't start too small, don't start too big. A 6 or 8 inch is probably about the right size, because a 4 inch is actually harder to hold and move around. Yeah, those are the main tips that I would give.
Nice. Oh, that's always wanted to do my own mirrors, but I'm such a visual person. I would need someone to like hold my hand through that process. I know eventually you get it down, but
yeah,
maybe one of these days.
Yeah, find someone locally. We used to do this in my basement back when I was still, kind of an advanced amateur and kind of learning. Just have some friends over and work on a bunch of different things, and find a group like that.
Okay, so we're gonna open this up to questions now. So if you guys watching have anything you'd like to ask Mike, go ahead and write that up in the chat, and that going. I know one of the first questions we have, how to get, let's see, this comes from Nicole. How to get good details of distant galaxies and faster optics because of wide field.
Well, a lot of my clients, I find, with good optics, don't use enough magnification. And that's probably the biggest mistake that they make. They never really fully exploit their optics. So you've got to push up the power. You can't change anything else. And that'll help darken the background a little bit and make things a little bit easier to see, make them larger. And then your eye will detect those more readily. And, the best way to see a galaxy is with a bigger telescope, as I like to say also.
And that's, you can get a lot of really nice high quality eyepieces nowadays that have higher magnifications. I know a lot of people I talk to with these scopes, and I'm sure a lot of Mike's clients are using a lot of the Teleview Ethos at this point, and the Delos, and those go all the way down to like 3.7 millimeter depending. And then there's
and the Delights as well. They also work with fast optics very, very well.
So yeah, if you want to get more detail, obviously dark skies help. Bigger telescope helps, but don't be afraid to push that magnification. There'll be nights where awesome. Oh, real quick, I'm just gonna glide this over Mike real quick. This is a picture right here of Mike's 14.5 2.55. I know he's got a picture of the 20-inch f3. There you go. That gives you an idea of how tiny this little.
Set it up on a stand to use it comfortably.
Yeah,
but it works really well in that configuration.
Get one more. That would be.
The 20-inch f3 is in the photo that you used for the title frame.
Yes, yeah, in the title frame, you guys will see Mike stand next to his 20-inch f3. There are pictures on his website. We already put the link for Mike's website down below in the description of this video. So if you're watching it live, or if you're watching this recorded, you can go down. It's loptics.com. So check that out. Next question for Mike is, has the pandemic caused you your wait time to be longer? And this comes from Big Gundy.
It's probably about the same, actually. because I was able to work a little more, get some things done. But then recently I've gotten some orders that have come in. So it's probably pretty similar to what it was.
Yeah. What is your typical wait time roughly at the?
Right now for smaller mirrors, probably starting at about 6 months. For larger ones, going up to 10, 11, depending on how large. So I've always had a backlog. It's hard to, it's difficult to catch up because I do custom stuff, so you can't have these things in stock. Usually, I do have some mirrors in stock here and there, but mostly people want what they want, and that's why they come to me. So it takes time to get glass, and then it takes time to do the work, and then it takes time to get it coated and shipped. So it's difficult to get it down too low, since I don't need to go into another career and do coding right now. Maybe someday, but I'd rather have someone else do that specializes in that. So it's hard to finish off a mirror in much less than several months, unless I just happen to have something partly done. And that's actually, I think that happened for Mike in his 20-inch f3.
Lucked out.
He lucked out. Yep, and I was able to finish it in an open time slot.
I know that's you know, I know we're Skywatcher and we're doing that. We're a very different business model from Mike. But if you are getting into the level of where Mike produces things, this isn't I'm gonna call Amazon and have it in 2 days. Like, this is something you're investing in. It's gonna take time to perfect it. That's what you're getting. So if you are thinking of getting scopes at this level and ordering from Mike or any custom optician, please keep that in mind. I've seen a lot of people on forums who are like, it's taking forever. It's like, well, yeah, because there's none other one like it. So just know what you're getting yourself into.
Everything's built the way that they want it, and yeah, it takes time to do that right.
You're commissioning a telescope at this point. You're not buying a telescope at this point.
Yeah, and I liked what you said earlier on about, I mean, telescope building and making optics. It's kind of an artistic thing. I used to do some art, and I enjoyed that, but don't really get to do that anymore except for photography. So it somewhat is, you have to get a feel for things. And there's a little bit of, well, it's experience and practice and that sort of thing that goes into it.
I know, like I said, being friends with Mike Spooner, who's another optician. I know he's not doing a lot right now, but you kind of figure out what you like to work with and what you're comfortable with. I know you're really good with these, 14 plus, real fast. Not that you won't do smaller stuff, because I've seen smaller stuff on your site occasionally. But you kind of figure out what works for you.
Right. Yeah, it also is what sort of stuff you have on hand and what sort of machines you have, and what sort of space you have, for testing.
That's a big thing that I don't think a lot of people understand. We have people call up Skywatcher and they're like, hey, I want you to make this. We're not set up for that. We have machines that are made to make the scopes that you see, and that's what they're made to do, where Mike is equipped to make different things. So just because someone makes optics doesn't mean they're set up with the machines to handle these different optical systems.
Yeah, and I don't do a lot of production work. I mean, at some point it'd be interesting to have that as, part of the business. So every time I do a different mirror, I have to use a different tool, have to set it up, make the polishing laps for it. So you try to group things if you've got similar mirrors and do them about the same time, because it'll help speed things up a little bit. But there's only so much you can do. And when you've got a large mirror and you need to set up a test path for it, that takes up a lot of the shop. You end up moving things to move things, as I say.
Yeah.
And, there are limits to that. So instead of making, 50 of the same mirror, I'd like to make 2 similar.
Just make the effort of going through the setup.
Yep. Different business models, but I'm a one-man shop with an occasional helper, so that's what I do.
Next question comes from Jeff. How much time does it take to make a 16-inch mirror?
Depends on the F number. in terms of hours or elapsed time, tough to say. Hour-wise, probably a good week and a half, depending on the F number. A little more, a little less, and depending on what. But that's not. You're not going to finish that in a week and a half. It's going to be spread out because there are other things in between there, and you're always working on something else, kind of in parallel. So roughly, probably 60 hours. It depends. That's just a guesstimate off the top of my head. Even though I try to keep track.
And then you factoring in what's the material? Do you have it on hand? How long it's going to take that? So that all affects order a mirror from Mike. That's all affected by.
That's why I list. Sometimes I list what some of the mirror blanks I have on hand that are kind of ready to start work. If I did have another similar one, I would try to run two through the process. Kind of usually serially, not at the same time, because you need duplicate tooling and stuff. But if you plan carefully, or spend a little time planning, then you can usually save a little bit of time.
If anybody has other questions, we only got a couple minutes left, but the last one I'm seeing here is from Jerry. What are your thoughts on active cooling of mirrors?
Well, I wonder what he meant by active cooling, because active cooling technically is a fan. If he's talking about attaching a heat sink to a mirror, then that can cause a lot of problems and even break glass in extreme cases. But pretty much every telescope that my clients put my optics in has some sort of fan, which is active cooling, so it's necessary. Ideally, you cool the front and the back of the mirror with a fan as uniformly as possible, because like I've said earlier on in the webcast, the thermal performance, the thermal issues are what are going to limit your performance the most if you don't have other issues in the system. So very important.
Well, another quick question from Jeff. How much does your 14.5 and 20-inch weigh?
The whole structure?
Yeah, the whole assembled.
14.5. I don't know. I can pick it up and carry it around. The total is probably maybe 50 pounds. It's built pretty stoutly. That's just a guess. I'd have to put it on a scale, maybe 60. But I can pick up the OTA and carry it. Probably 40 to 60. The 20-inch F3, it rolls on wheelbarrow handles, so I'm going to guess it's 150 pounds maybe. With the whole structure.
Truss anyway, so you'd break it apart if you're really traveling.
Yeah, the heaviest component is the mirror cell with the mirror in it, and that's probably, it's a thin mirror. I'm going to guess 40 pounds. The mirror, I think itself is about 30. It's 1.25 inches thick Pyrex blank. So, I'll point out right there that a lot of the 2-inch thick mirrors that are out there, kind of the traditional thickness, for me, they're just too thick. It's just unnecessary. So a 20-inch that's 2 inches thick is heavy. A 24-inch that's 2 inches thick is really heavy. But if you thin those down a bit, they get a bit more manageable. And it's safer to handle them too, and of course they cool a lot faster.
Because your average 20 that I've seen you make is like 1.25 inch edge.
I like about 1.3 to 1.4 inches in a 20-inch size. Yeah, mine is 1.25 inches. The 20-inch F3 that I did for myself 10 years ago, because I still have a few of those blanks left actually, but they're challenging. It takes some extra time because they're so thin in order to avoid astigmatism and keep an eye on things. But when you can just pick them up really easily, it's so nice. And they cool very quickly. I actually don't have fans on my StarMaster. I should. I just haven't had time to put them in. But I live in central Illinois, so I'm out here in the prairie. Usually there's a breeze, and so that helps quite a bit. Or I can set up a box fan or something if I really need to.
Very cool. I think that pretty much wraps up all the questions. If you guys have questions and we didn't get to them, or something pops up into your head and it's directly for Mike, you can always visit his website, which is www.loptics.com. If you want to see what he has in stock, it's up there. If you want to read his articles, which are really informative if you're looking to do testing or pretty much anything, there's a ton of them up there. It's actually fun to read Mike's excursions around the world too, with clients, so you can check that out. And that link to his website is below. So
I would have to say that the one thing I probably ought to mention is I didn't expect, when I started this, but to be able to go and visit people in different countries, amateur astronomers, and see how they observe with them and see a little bit how they live has been kind of the unexpected bonus of what I do. So I want to thank them for hosting me in the past and putting up with me. And we've had some great observing, some great beer, and some really good times. And I look forward to that in the future when we can actually travel again. Yeah.
Well, Mike, thank you very much for taking the time. I know you're extremely busy doing what you do.
I will say right now what I'm doing is about ready to paint some stuff. So I'm got some new space that I've been working on for the shop for a while. So I'm going to go prep for painting and paint some ceiling fans and all kinds of walls and stuff in the next few days. Then be able to use the space.
Well, now you're opening up more, can hold more glass and move to the next year at that point.
So I don't have to move stuff to move stuff.
There you go. I think everyone who uses telescopes or works on telescopes know how that is. I know if you could see everything beyond this frame is a disaster. But
for optics, it really pays to be able to set certain things up and not touch them for a year, because then you can use the same test setup. And that's what I'm trying to get to, so it'll save me some time and make me a little more productive.
Very cool. Well, that does it for today, guys. Thank you very much for watching. Like I said, if you have any questions for Mike, you can go to his website, www.loptics.com. All the information you could ever want to know is up there. It's really cool. He actually keeps a history of all the different projects, for most of the projects up there, so you can see all the different optics that have been done. If you have questions on any of his mirrors or any of his work, please email him directly. And then if there's a topic that you want us to cover in the future, you can email Skywatcher at support@skywatcherusa.com. And if you wanted to see what's going on the webcast moving forward, you can always subscribe to this channel, which I know is the most YouTube thing on earth, but hey, that's how YouTube works. But thank you all very much. Mike, thank you again, and I hope you have a great weekend. And clear skies, everybody. We'll see you next week.